Good morning, everyone. We are the Group 4.
And we will be performing Experiment 7 titled Field Density Test by Sand Cone Replacement Method. The equipment and materials that we are going to use are the following:
density plate,
trowels, sand,
sand cone density apparatus, metal pan, and then the drying equipment.
This procedure was adopted from ASTM D15560 Standard Test Method for Density and Unit Weight of Soil in Place by Sand Cone Method. First, measure the weight of the sand cone density apparatus. After weighing the apparatus, fill up the cylinder container with a specially graded sand up to about 10 mm from the top. Next, weigh again the cylinder with a specially graded sand, accurate to 1 gram. After the weight was determined, attach the sand cone to the cylinder and pour it in a clean plate surface. Wait until the sand will fully fill up the cone and weigh again the mass of the remaining sand in the cylinder. Next, refill the cylinder with the sand such that it gets to the initial weight. After that, horizontally position the base plate on the level ground surface where the density was to be determined. Using the base plate as guide, carefully dug the soil with the trowel. Next, place the excavated soil in the metal pan container.
The excavated hole must be 5 inches deep. Then, the metal funnel was positioned on the groove of the base plate, and then the valve was opened. It is open until the sand completely fills the hole and the cone, wherein there is absolutely no movement of sand from the container. The valve is closed, and the sand from the cone was placed again in the container so that we can measure the weight of the sand from the hole alone. Next step is to measure the soil that was collected from the hole. Then, just repeat the same procedure for trials 2 and 3. After that, dry the collected soil samples by placing it on the laboratory oven. Kaboom! Oh no. Shit, guys. Okay.
Okay.
Apel ka dito.
Okay.
And then, we can determine the moisture content of the soil samples by their weight before and after drying them.
After we obtain the dry weight of our soil samples, these are the result of our field density test using sand cone replacement method. We will calculate the field density of that particular location. This includes the bulk density of wet soil, bulk density of dry soil, dry weight of the soil, and moisture content. For trial 1, the bulk density of wet soil is 1093.07 kg per cubic meter, and its dry weight is 2.024 kg, and the moisture content for trial 1 is 19.84%, and the bulk density of trial 1 is 1090.90 kg per cubic meter. And for trial 2, the bulk density of wet soil is 976.19 kg per cubic meter, and its dry weight is 1.768 kg, and then moisture content is 13.75%, and the bulk density is 974.85 kg per cubic meter. And lastly, for trial 3, the bulk density of wet soil is 1,151.32 kg per cubic meter, and the dry weight of the soil is 2.269 kg, and the moisture content is 13.56%, and the bulk density of dry soil is 1,149.76 kg per cubic meter. And if we will get the average of these results, the average bulk density of wet soil in that particular location is 1073.53 kg per cubic meter, and the average moisture content is 15.72%, and the average bulk density of dry soil is 1071.84 kg per cubic meter. In conclusion, field density test of soil is conducted in the field to know whether the specified compaction is achieved or not. In our experiment, the density of the soil falls from the range of 1000 to 1300 kg per cubic meter. This means that the soil is a loam type of soil which has a very weak structure. The term weak means that the cohesive forces holding the particle together can be easily overcome.